Hello everyone, welcome back to my YouTube channel Code A to Z. So this is a new project which is basically a book recommendation model. Uh, Here I have used two different types of filtering techniques for the recommendation, which is the content-based filtering and collaborative-based filtering. And I have combined both of them to make a hybrid book recommendation system. And it uses two different techniques of the models like a neural collaborative filtering model and CNN model. Uh, so how it is works? So let us take a test for like if I want to recommend different books which is more similar to this, how to build a time machine, and these are the number of recommendations. So this is a slider, so we can increase or decrease the number of recommendations and click on the recommend. Then you can see there are four different similar books according to the number of recommendations are displayed here. So this is the book which I have already chosen, and the similar books are these. These are sorted based on the ratings, like 4.34 rating, and another one is will be having a less rating like 4.08. But but all these books are very much similar to the selected book. Okay, and author, genres, descriptions are also displayed along with the cover page of the book. Now you can test one more like Python, Think Python, and if I want to recommend 15 books, so these are the different 15 books like functional programming in Scala and the Linux command line and introduction of to algorithms and a much more different similar books which are uh, related to the current selected book, which is a Think Python. Okay, and it also tell about the number of pages in the books and the genres related to that books. So let us start working on the how this recommendation model will be built. So I will not code, but I will display my Kaggle notebooks. So let us start from there. So I have divided the whole code in three different notebooks, three different Kaggle notebooks. First one is related to the cosine similarity model, and another one is the NCF CNN model, and finally we will combine both of these recommendations and will create a hybrid recommendation model. Okay, so let us start with the cosine similarity. So I think many of you are already familiar with the cosine similarity recommendation models, as I have already developed a movie recommendation model using the cosine similarity. You can check out the video from my YouTube channel. So first, before moving to this model, so the required parameter of any model is the input data set. So this is the input data set which I have taken from the Kaggle, and it consists of 100 uh, thousand books data set. So let us see what are the different parameters present in this data set. There are columns like author, book format. Wait, we can open this in a new tab so that you can read it properly. So this is the data set. It consists of 13 different columns, and size of the file is 120 MB. And this is the author, the name of the author or authors of the book, and the format like a hardbook cover or paper book, and different formats are present. And this is the description, which is all the description of the books are in English. I have already checked. And the genres, they are comma separated, and image link with the cover page of the book, and ISBN code of the book, So this is a unique index which is being provided by the international community of the books, so that it can be found out very precisely and categorized it globally. And this is the ISBN 13 code of the book. So this is a 13 digit long digit number code of the book, and another feature is the link. This is the link related to the book, and the good links for good read links of the book, and the number of pages of the book. Like this book has 0 number of pages, and this book has 576 number of pages, and this is the rating, which is the average rating, like from 5 to 5, 4, 3, 2, 1. And these are the reviews, number of reviews the book has, and the title of the book, and at last we have the total ratings present on the book. So this is very old data, but it can be very useful and beneficial to build and learn a recommendation model, so that we can create a AI based recommendation model. Okay, so let us start with the cosine similarity. So I have used TPU to use this notebook because it requires a large amount of memory. That's why I have used the TPU, so that it will create the cosine similarities recommendation model very easily. So this is the file at first reader. So this it consists of ones, tens, hundred, thousand, 10,000, and 1 lakh. So 1 lakh entries at the 13 features. So now I have just renamed the different column names, so that it will be very easy for me, so that it can be readable. Okay, so these are the different renaming, so that it can be useful for me. Then I have to drop the duplicates at first, and finally, and secondly, then I will be describing the whole data set, so that I will find which feature is so that the features are equally distributed. Okay, so I am seeing that the features are very well equally distributed. Okay, so let us move ahead. Then I will check the null entries present in the data set, and I have removed the different columns, rows of the data set based on the genre and ISBN number, image, title, and description. And finally, I have left with the 73,000 rows, and now move ahead. So before moving ahead, I've chosen that I have to take those dataset which consist of total number of ratings must be greater than 50, so that it will be so that it will be consist of a very good number of books, and they should be highly rated. Okay, so that's why I have chosen this filtering format. From my side, you can choose whatever you want, like. What are the number of pages, so the rating should be greater than 4, and different other parameters you can also choose. So by choosing this parameter, then I have left with the 56,000 rows. So this is very much a data set for me. So to build the data set, and then I have saved this final data after cleaning the whole data set, because it is not required too much pre-processing, and that's why I have just saved the file here. So this is the checkpoint one. After that, I have created some number of users and number of ratings, so that it will be very much beneficial to create a cosine similarity. So randomly generated the number of ratings which is being provided by the user, like 5, 4, 3, 2, 1, from 5 to 1. That's why. Then I have added those columns to the final data set and created the whole data set at last. User ID and rating, and like 267 user gives the rating to 5. This is the randomly generated, so that it will provide somewhat rough decision, but it will be precisely decided based on the rating and the number of ratings and total ratings. But I've also used this parameter so that there should be like somewhat so that it will be less fluctuated. Okay, so let's move ahead and after watching the information of the data set, then I have seen some of the columns having the 64 integer data type. So I have to I'm thinking to reduce the data size of the file. Then I have converted it into the int 64 to int 16 and finally save this file so that it will be further used while building the Streamlit application. And at last, I am checking for the average rating distribution so that it will be fairly distributed. So this is a normal distributed graph like something like this, and maximum rating is around the 4. So this is very much fair. Then I am started working on the description column and fill null values with empty if any null values are left, and then converted the description column from into the lowercase letter, and also the converted the title into the lowercase letter, and finally combines description, title, and genres so that it will be very much similar to the content of the file and easily recommended by the cosine similarity recommendation model. So I had passed the metrics of the sklearn library, which is the TF-IDF vectorizer. Then passed this TF-IDF vector, which is consist of the 56,000 and 451 rows and 56,451 columns, and converted the data type from integer to float, so that it will be very much beneficial for the cosine similarity to categorize the and find the vectors which are very much similar and uh, group them so that it will be recommended very precisely. At last, I am saving the file and created a function so that recommendation books will work. So this is the function. At first, I am finding the that book which is having the ID from the final data. Then I used that ID to find from the cosine similarity and enumerate from the whole cosine similarity database, and extract the whole list which is very much similar to that index, and I have sorted based on the similarity scores. Okay, then at last from them I have recommended 10 books. So extracting the 10 books and storing the similarity scores, and the similarity scores will provide the index and store those index from 1 to 11 and like 1 to 10. So that's why book indexes, and those book indexes title, image, and authors are extracted and form a final data and return that data from that function. So let us assume this is a required name of the book which I want to be recommend. So the different other recommended books based on this book. So these are the different 10 books with their book cover and author name. Okay, so this is the book. So if you like, so please upvote or share it. And if you have any query, so you can just comment here, and I will definitely answer your query. Okay. So please also upvote this notebook and share this notebook. Okay. So thanks for this. And this is the cosine similarity recommendation model is formed. So this is the first part which I have covered of our AI based recommendation hybrid recommendation model. So let us move to the second part, which is the NCF CNN model. So first I have tell you about the NCF and CNN. So basically NCF is the neural collaborative filtering, and CNN is the convolutional neural network, which you have many of you have already familiar with the CNN models. So you can say I have implemented and trained a neural collaborative filtering model using user and book embeddings, and also passed that trained and implemented a convolutional neural network model to predict book ratings based on descriptions. So I am just getting the information based on the ratings and books embeddings and user embeddings, so that it will be combined by combining the cosine similarity and neural collaborative filtering and convolutional neural network models to provide a robust recommendation system. And finally, we will be creating a Streamlit application to provide an interface for users to get book recommendations, right? So let us move with the neural collaborative filtering. So basically, I am also telling you one more point, like it is the ability to learn user and it items embeddings that capture latent factors in the data, like whatever is being missed by the cosine similarity and CNN. So it can be easily captured by the neural collaborative filtering because we have not decided a particular regex for the model, so that's why it will be very much beneficial for us to create a AI based model so that neural can also create its own logic to recommend the different books. So okay, so let us move with this notebook. I have used the last saved this final data in our this in this notebook because I do not want to move with this whole things again and again. So that's why I have used the final data with ratings. This is the path which I have used from here. And now I have used GPU to run this notebook, and I have used TPU to run this cosine similarity model. Okay. So GPU is required because we are creating a neural network model. So that's why GPU is very much robust for to create a neural network model. So let us move with this more data set, which is being already filtered by us and pre-processed already, like it contains of the 56,000 entries with 15 columns having the user IDs and ratings, which are being randomly generated by us. Okay, so let us move with the model building part directly. So this is the NCF model building part. First, I am watching the information of the data set. So it consists of all these 15 columns, which you have already seen, and it consists of book format consists of some null entries, but rest of them uh, are not having, like this is also having some null entries. So these are not very much required because we are using user embeddings and rating embeddings for the NCF model. So that's why we are taking all only these three columns. Okay. So let us move with this part, and I am getting this sample from this data set, user item data, and creating the embeddings like train and test after splitting the data set so that it will be after uh, tested before being uh, completing the model. Okay, so this is the first layer of our model, user input, and this is the user embeddings layer. So like using the user embeddings, okay, and it consists of the number of users, and then at last layer is consist of the vector, which will be flatten the layers and it will create a 2D layer so that it will be passed into the next layer. So this is the next layer which consists of the item input. So this whole code consists of the user embeddings, and this whole code consists of the item embeddings. So that's why I have chosen this user ID, ISBN, and ratings. Okay. So this is the number of items which is being taken from the ISBN because it consists of the unique entries, and user IDs also consists of the unique entries because we have created a randomly generated numbers which is not being repeated. But still I am using the non-unique so that any non-unique entries will not be passed here. Okay. So This is the after creating the user embeddings layer and the item embeddings layer. Then I have concatenated both the layers like user vector and item vector. And after concatenating, I have passed the layer to the dancing layer, which is the relo activation layer, and with consisting of the dropout layer of point 3. Then after this is the output layer, which is having the linear activation function and naming the output to this layer, and finally pass with the dropout layer, passing from the dropout layer. Okay. So finally, we have created a model which consists of the user input and item input with the output layer. Okay. So this is the input matrix and this is the output matrix. Okay. Finally, compiling the whole model by using the MSE, mean squared error is the loss matrix, and the mean absolute error is the matrix of our model. So after training the whole model on the box of 20, batch size consists of 64, and passed it with the validation data, so that it will be very much beneficial to build the neural collaborative filtering model based on the embeddings. Okay. So after plotting the graph of the our training model, so you can also check out the hidden inputs like what is being the processing from this batch, like it consists of the 706 batch size while processing through the one epoch. Okay. So this is the our model MAE graph and model loss graph. So you can see the validation MAE is similar, like around zero point 0.2 and 2.3 in between, and model loss is also somewhat around zero point 1 to 0.2, around zero point 1 to 0.2. So it is very much fair, and you can see this is the our matrix of after evaluation on our testing data set. Okay. So I have finally saved this NCF model. So this is our NCF model is completed, and we have finally created a neural collaborative filtering model, which is basically using the user embeddings and item embeddings. Okay. So let us move with the CNN part. So CNN part, you all have familiar with the convolutional neural network, which is having its ability to capture like complex patterns from the data, like through the hierarchical feature extraction method. So that's why I am using the convolutional neural network to predict the book ratings based on the textual descriptions. Okay. So that's why I'm taking the max size of the 5,000 maximum words and maximum length of the 200 and one go. You can also increase this based on the GPU availability. Uh, this is based on yourself, on your system's resources. That's why. Okay. So let us first create the tokenizer so that it will be used uh, to uh, to read the whole description in one go, because we are first because model is basically using the 0 1 methods only, like working on the 0 1, not on the text or not on the 2 3 4 any other numbers, any other things else. So tokenizer is like to convert the whole text into the tokens, and provided the tokens to a different unique number, so that it will be uh, fit in the model. Okay. So I have created a tokenizer which consists of the maximum words of the 5,000, and after fitting the whole description to the tokenizer, I have passed in the tokenizer and created a sequences, and the sequences with the maximum length. So these sequences are passed to the model, will be passed to the model, so that it will be very much very easily trained. But before moving ahead, I have splitted the sequences into training and testing data set, like in the 80% and 20%, which is being normally used while working on the machine learning or any other different types of the machine learning or deep learning models. So I have passed those embeddings with the maximum words and the input layer having the 128 neural networks, neural neurons, and then consist of the convolutional neural network, which consists also of the 128 neurons with the five value activation with the value activation functions. Then with the pooling layer, then is the dense layer, then dropout layer, and then finally a dense layer with the output layer with which consists of the one neuron. Okay, so here I am also using the MAE and MSE for the model compilation. Then Adam is the optimizer to optimize the model so that it will be very much best fit uh, while building the model. Okay. So I have also running this model also on the 20 epochs with the batch size 64 and display validation split is 0.2. So after training the whole model, then I have plotted the graph for this also. So the accuracy of this model is around similar to the NCF. Like the graph is also very much similar to the NCF model. So after evaluating the data model, then the MAE mean absolute error is around 0.23, like 0.23 to 0.24, which is very good. Then saving the model of the convolutional neural network, then comparing the both the models is the last point of this notebook. So this is the graph. You can see the dashed line is the NCF model and the straight line is the convolutional neural network model. So you can check out this notebook, and if you like, then please import and share this notebook. And also, if you have any query and any questions, so you can comment in this notebook. And thank you very much for this second part of this notebook. So let us move with the combination of these both models and will create a hybrid recommendation model. So this is the hybrid recommendation model which is which is being used both the notebooks as an input. Okay, so you all are thinking like why I am not creating all these things in one notebook. This is because cosine similarity required TPU, which is a very large space with large memory is required. But NCF and CNN models are required for a GPU, which is requiring a parallel fast computation. So that's why these two different notebooks are being created by me. And then finally, I have compiling both the notebooks into a third notebook so that hybrid recommendation model will be created very easily. Okay. So let us move with this part. So this is the cosine similarity model path, and this is the NCF CNN book base URL. Okay. So I have first imported the required libraries which is being used, and these libraries are also being used while creating a Streamlit interface. Okay. Because I am just compiling the whole things into a notebook, and these whole code is also being used while creating a Streamlit interface. Okay. So let us move with this part. So this is the code which I have been used from the cosine similarity. You can see the name of the function which is being present at last in the model. So this is the thing. And now I have created a new function of the hybrid recommendation model, which consists of the first is the cosine similarity recommendation. So I have getting the recommendation from the cosine similarity at first. Then I have created I am using some user IDs and books IDs for the NCF model because NCF model is um, created based on the user embeddings and item embeddings. So that's why I need to create a user tensor and book tensor to pass through the NCF model. So I am passing this is the input array, and this is we get from the zeroth row and converting into the numpy array. So this is the NCF model output, which is the rating prediction. So rating are being predicted from the NCF model and converted into the linear list. Okay. So NCF recommendations are also appended with the book ID and rating predictions. and sorted based on the ratings. Okay, because I have used the X1, so this is targeting to the rating prediction. Okay, so that's why I've sorted based on the in the reverse order, decreasing order, so that the highest rating will be on the top and the lowest rating will be at the bottom. Now this is the CNN recommendation, and CNN recommendation is basically built on the description feature, which created the tokenizer, and tokenizer is passed through the model to create to find the similarities and different complex patterns from the description and textual descriptions. So that's why I've used this method and created a function for this also, and converted the tokenizer and passed to the sequences, and then used the sequence to predict the CNN model, and combined and created a CNN recommendation. And this list is being created and also sorted based on the rating predictions. Okay. Now at last, after getting the CNN recommendation, NCF recommendation, and cosine similarity recommendation, I have created a combine and rank recommendation. Okay. So how this is being created? This is like I am using the set so that there is no chance for the uh, like you know the set having the property of uniqueness, so that's why I used the set at first and then converted the set into the list, and the finally convert combined recommendation is being filtered, and I have created returning these values: title, author, and genre. Okay, so this final recommendation is being written at last. Okay, so this is the whole function which is being created, hybrid recommendation. So let us move with this cosine similarity. So at first I have read the model, I have read the file, then I have load the NCF model, load the CNN model, then created a tokenizer and passed all things to the hybrid recommendation with the title of the book which is being required to be recommended. So I have passed all these things to the hybrid recommendation. So this is the thing which I have passed to the hybrid recommendation model, and this is the, you can see the things which is being recommended by the model. So this is the title, and from this title we can filter out the image URL and different other properties from the final data set which is being saved in this final data with ratings, and we will be using this file for building our Streamlit interface also. Okay, so you can see this is our Streamlit interface which is being used book cover, title, author, description, genres, pages, ratings, and very much else. Okay, so let us move with the Streamlit interface. This is the Streamlit interface, and it consists of all these code which is being already discussed in the recommendation cosine similarity recommendation model, and this is the hybrid recommendation code which consists of the cosine similarity recommendation, NCF recommendation, CNN recommendation, and combined rank based recommendation. Okay, and finally returning the recommendation with the title of all the recommended books. Okay, so this is the loading the all the models and all the files, and finally created the tokenizer, and all these beings are loaded and written. So this is a function which is being used to display the data, how this data is being displayed. So like a particular book data is being passed to this function, and this function will use the data. Uh, uh, so you can check out this code from my GitHub, which is being also uh, addressed in the description. So this is a this is the title which is being select box. This is the slider which is used maximum minimum value is 1 and maximum is 220. Okay, and finally if we click on the recommend, then Just it will be sorted the based on the ratings also. And this is the recommendation of your, this is the selected book, and pass the data to the function, so that this book is also being displayed. And this is those books which are being similar to that selected book. Okay, so this is and the complete application. And thank you very much for this application, and for your support. So just check out the code from the description, and if you want any changes or if you have any questions, so you can ask me in description or also ping me in the Kaggle notebook. Okay. So thank you very much. Uh, so we will be meeting in our next project. So bye bye.